So here we have the notes for section 6, the graphical transformations. So at the top we've got some definitions. Transformations are functions that move or map points to points, so it's essentially just move a point around. So rigid transformations leave the size and shape of the graph unchanged. Non-rigid transformations distort the shape of the graph. So down here, the first two, vertical and horizontal translations. So a vertical translation shifts the graph up or down. Horizontal translations shift the graph left to right. Down here we have the rules. Horizontal translations appear inside grouping symbols. Now grouping symbols can be anything like parentheses with powers outside. They can be absolute value bars. They can be square root symbols. They can be cube root symbols. Anything that groups x and a number together. Vertical translations appear outside grouping symbols. Now the one other thing to remember is that horizontal translations are actually always the opposite of what they appear. So if you notice here you have x minus c and the translation is to the right. X plus c, the translation is to the left. Normally an addition sign will move things to the right, subtraction signs move things to the left. Vertical translations do exactly what they're supposed to do. Plus c moves it up, minus c moves it down. So example 1 here, describe, and that should be how the graph of y equals the absolute value of x can be transformed to the graph of the given function. So here our change is outside, so it's going to be a vertical change. It's negative, so it's down, and that's many units. So this one is down 4 units. So here, x plus 2 inside the bars, so it's inside, so it's going to be horizontal. It's plus, so it's the opposite, so it's going to go left 2 units. Now if you wanted to, you could graph the original equation, y equals the absolute value of x, and the new one, and just look and see what the graph did, which is what example 2 talks about. So in each case, the dashed line is the graph of x cubed, and then they want to know how did you get these new ones. So for example, for A here, this graph went down 3 units. So it'd be x cubed minus 3. No grouping symbols because it is a vertical motion. This one went left 2 units. So it's going to be x plus 2 grouping symbols cubed, since it went left 2. Opposite sign, grouping symbols for horizontal, power stays outside. Similar thing's going to happen here. This one went right 3 units, so grouping symbols x. To go right, I need to subtract, which is the opposite, and then put my cubed outside. So these would be my equations that would give me the transformation. All right, so we have reflections. So these 2 points are reflections of each other across the x-axis. So x-axis reflections flip the y's. If you change the sign on the x's, you reflect it across the y-axis. So that's how reflections work. On the flip side here, you have how to do it with equations. So if you need to reflect across the x-axis, you multiply everything by a negative value. If you reflect across the y-axis, you replace all x's with negative x's. And if you reflect to the origin, you replace all x's with negative x's and multiply everything by negative 1. So it says find the equation for the reflection of this across each axis, so x-axis and y-axis. So for x-axis, the rule is y equals negative f of x. So what that means is multiply everything by negative 1, which is as simple as just putting a negative sign out front. There you go. That's reflected across the x-axis. To reflect across the y-axis, the rule is y equals f of negative x. Replace all x's with negative x's. So 5 times negative x minus 9 over negative x squared plus 3. So y-axis, x and y. So here, prove that a graph of an even function remains unchanged when it is reflected across the y-axis. So the simplest even function is y equals x squared. So the rule for reflect across the y-axis is f of negative x. So this becomes y equals, oops, I'm off the bottom of the page. So it looks like that. So replace the x with the negative x. Now when you square a negative number though, it's the same thing. So an even function is always reflected across the y-axis. All right. So just some rules for absolute values. Vertical stretches and shrinks are down here by a factor of 3. So let C1 be the curve defined by this. Find the equations following non-rigid transformations of C1. A vertical stretch by a factor of 3. So vertical stretches multiply everything by the factor. So C2 is equal to 3 times C1, which is going to be 3 times x cubed minus 16x, which is 3x cubed minus 48x. Horizontal shrinks by a factor of 1/2. So horizontal shrinks appear inside and they act like the reciprocal. So this is going to replace all of the x's become 2x's. You multiply the x by the reciprocal. So if my original equation was x cubed minus 16x, my new one is 2x cubed minus 16 times 2x. So for vertical, you multiply everything by the factor. For horizontal, you multiply the x's by the reciprocal, and you use grouping symbols. So this would become 8x cubed minus 32x when you simplified it. Okay, combining transformations. So the graph of y equals x squared undergoes the following transformations in order. Find the equation of the graph that results. So I'm going to start with y equals x squared. So the first thing that's going to happen is a horizontal shift of 2 units to the right. So that goes inside grouping symbols, and since I'm going right, I subtract 2. So that's done just the first step. Vertical stretch of a factor of 3. Vertical stretches multiply everything by that number, so the 3 goes up front. A vertical translation 5 units up. Vertical translations appear outside grouping symbols at the end, so plus 5. So these are the steps. So original equation, then that equation shifted 2 units to right, then this equation stretched 3, and then this equation moved up 5. So the end result should have all 3 of these things being done to it. So that's why I applied it to the previous row and didn't just go back to the x squared each time. Now this one is actually going to be the exact same thing. You're just going to do the steps in the reverse order. So y equals x squared. Y equals x squared plus 5. There's a vertical shift. Y equals 3x squared plus 5. So that's the vertical stretch. Y equals 3x minus 2 squared plus 5. Okay. Example 7, the last one here, gives you a graph and then has you do some transformations to it. So let me sketch in some axes real fast. There we go. Okay, so on our original graph, there's 3 important points. There's that point there, which is at -2, 0. There's that point there, which is at 0, 2. And there's that point there, which is at 4, 0. So the graph of f of x is shown below. Determine the graph of the composite function 2, f of x plus 1 minus 3, showing the effect of a sequence of transformations on the graph. So I'm going to start with the 2, because you always do your stretches first. So that 2 out front, since that's a vertical stretch, is going to multiply all of the y values by 2. So this point here, that's at -2, 0, is actually still going to be at -2, 0, because 0 times 2 is still 0. The x values don't change. This point at 0, 4, or sorry, that's at 0, 2, will be at 0, 4, double the y value. This point here will still be at 1, 2, 3, 4, 4, 0. So the graph will look something like that. So I've just doubled all of my y values. So now I'm going to do the horizontal shift. So it's +1, which means everything's going to move left 1 unit. So this point here, that was at -2, 0, is now going to be at -3, 0. This point here that's at 0, 4 is now going to be at -1, 4. This point here that's at 4, 0 is now going to be at 3, 0. Each point moved 1 unit left. And then the last one, so this was everything times 2, so y times 2. This one was everything left 1. And the last step is the -3, so everything's going to have to go down 3 units. So this point that's at -3, 0 is going to be at -3, -3. This point here that's at -1, 4 is going to be at -1, 1. This point here that's at 3, 0 is going to be at 3, -3. Every point goes down 3 units. So So that is what my graph ends up looking like after I've done those 3 transformations. Stretch by a factor of 2. Everything goes left 1 unit. Everything goes down 3 units. That is the end of this section.